Hi folks, DD Solar here. You know, those HEPA filters that you can buy for your home or office have gotten really expensive by now. This happened recently after the so-called event that nobody's allowed to name, but I'm sure you know what it is, where people started really worrying about filtering the air in their home from germs and bacteria and dust and whatever else they don't want to breathe. I have several of these filters. I'm a big fan of them, but they are incredibly expensive, and I was always wondering how to get around that problem. I'm going to show you how to make your own HEPA filter, which uses off-the-shelf replacement filter cartridges that are widely available, and also how I run it off of a solar panel so that it doesn't run up my electric bill and it automatically comes on when the sun comes up and turns off when the sun goes down. In this case, I will be filtering my workshop air automatically using the power of the sun, and I won't need to worry about power bills or anything like that. Just need to check the filter once in a while to make sure that it is clean and that the fan is operating. Okay, let's get started with this project. HEPA filter replacements are usually fairly cheap, although I have seen some expensive ones. This particular one, as you can tell by the size of my hands here, is, probably for a bedroom. It's not for your whole house, and it cost me $5. I think $5 is a bargain because I couldn't make something like this for $5. Even if it was $10, if I get 6 months or a year out of this, I think it's a good deal. The point of this video is to show you how to take most off-the-shelf HEPA filter replacement cartridges, such as this one here, and make your own HEPA filter, and do it for as little money as possible. At the end of the day, a HEPA filter is simply a plastic box with a centrifugal blower or fan in it, and a filter cartridge, much like this one. So I took a plastic box, I hacked a hole in it, and I shoved the filter into it, and I have part of the makings of a HEPA filter. It's not the best thing to look at, but it'll do the job. This particular box is brittle, clear plastic. It was a poor choice, as it's much harder to work with, but you can use any plastic box. For example, you could use something like this, simply a plastic storage box. That's all it is. The challenge, of course, is sealing it up because you don't want to have air infiltrating inside the box. That's supposed to stay clean. So there is some challenge in cutting a box like this, but honestly, it's a lot easier to cut this type of box than the one that I'm showing you in my video. Any cheap plastic box will do. As a matter of fact, you could even use a cardboard box. That would not be ideal, but it sure would be cheap. Where the filter goes into my box, I'm adding neoprene rubber strip. This is a gasketing material. It sticks extremely well, and it's kind of a spongy, rubbery texture. So I'm going to go ahead and put the rest of the rubber strip on here. Now at the corners, it's important to have a little bit of extra gasketing material, just a tiny bit, about 1 millimeter, so that you can put a little bit of pressure at the corners. The corners could leak air, and so my goal here is to not have any air leakage at all. So I'm going to add a little bit of extra rubber right on the corners there, in the hope that that will keep air from slipping past. So I'm going to push this end up a little bit. There we go. Make sure it butts up against the other corner. That's to keep air from sneaking past this line right here. You don't want air creeping past. The goal should be to keep unfiltered air from getting inside this box, because if it does, dust and stuff will build up inside, and you don't want that. I hope the camera footage isn't too bad. It's a clear box and it's kind of hard to see, and this camera has a very narrow field of view. But again, this is very simple. You're just cutting a hole in a plastic box. So now that I've got the gasketing material in there, I push the filter in and it has a nice snug fit. It's a friction fit. And this will be enough for me to test the filter and get it working. I may install some kind of latch or something to just push down the filter a little bit. Right now I'm not too concerned about it. This box is particularly challenging to seal, especially where the hinge is. So what I did is I took the sponge neoprene rubber strip, which is what this material is, and I applied it right past the hinge here at 90 degrees to the door. And there's a lip on the door that's going to come and press right down on this foam here, and it'll make a really good tight seal. This stuff is not exactly fun to work with, but it sticks really well, and it makes an excellent air seal. Now I've got to install it all the way around this box on the opening, and I'm going to try to use one continuous strip instead of cutting it. We'll see how that works out. And I'm just putting it flush with, nearly flush with the top. Now I've carefully applied the neoprene strip all the way around. It makes a nice seal. Now I have to find a way to secure this door shut so it doesn't accidentally open and let in air. And I'm over at my other workbench. This is a pack of L brackets that I have. I've had these for quite a while. And I'm going to try to use these to fasten the box shut using M3 plastic bolts. Now I'm going to try some hot glue to see if I can attach these L brackets to the side of the plastic box. Hopefully this will be enough to keep the box closed. It's not perfect. There's better ways to fasten something, but if you're in a hurry, hot glue is definitely faster than anything else I can think of right now. Now to do this, I'm using my solar-powered Ryobi hot glue gun. It's actually directly attached to a 100-watt solar panel, and it's been working pretty good for me. It runs good and hot, and there's the cable going to the solar panel. It's just got a solar panel plugged straight into it. There's no batteries in here. It's just an empty plastic case. And I really can't tell any difference between solar power and battery. It's very, very hot. It's easy to burn yourself, actually. I think these L brackets are going to do the trick. They seem to be working so far, and I have quite a lot of them, so I'm willing to use them. And I think I'll start with 4. And these will just be the method that I use to keep the cover shut, because I never need to open it really, unless something goes wrong with the blower. To change the filter, I don't need to open the box at all. This is really a permanent fix here. I've been trying to improve the camera lighting and just generally get better with the camera. I hope this footage is clear enough. It's not rocket science. I'm just putting a little hot glue on here. Might add 1 or 2 more later, but I'll try them like this for now. Okay, that's 4. There won't be a lot of pressure on these. The next step is relatively simple. I just need to drill 4 holes and use them to run the nylon bolts through. And I'm really just using my eye to see where the hole needs to be. I'm not doing this perfectly straight. Okay, in order to fasten the door onto these L brackets, I'm going to use my favorite thing in the world, which is M3 nylon standoffs. I have quite a few of these, and I use them for absolutely everything. And I'm simply going to take a really short standoff, looks like this, and a short screw, looks like that, and I'm going to put the standoff on top of the L bracket and just thread the screw in from underneath. That'll give me a threaded mounting point for another M3 standoff. Or I should say an M3 bolt, or anything I want to put in here that's M3 threaded. It's probably hard to see anything because my hands are blocking, but I'm just threading it on there. Here you can see the holes that I drilled line up more or less with the M3 standoffs that I installed, so I can just insert a plastic M3 bolt right into the standoff there and tighten it down, and it will hold this gasket surface here really firmly. It really doesn't take a lot of pressure. This foam is really good. It's really nice and spongy, and it does seal very well. But these screws are just insurance to make sure the air doesn't start creeping in underneath, or that this door doesn't open slightly and let in air and let it go past the filter. The next task is to install a centrifugal blower. You would not want to use a normal muffin fan or brushless DC fan. That just isn't going to have the guts to get the air pulled through the filter and outside the case. You need a blower, something that looks like this on the inside. They have these sort of blades that look like a squirrel cage or something like that. So that's what they look like. It's a centrifugal blower, and the air comes out here. Now, just a quick word of warning out of courtesy. These are incredibly dangerous, and they will shred your fingers. This is a very powerful blower, and if you get your finger in that, you're going to have problems. So just be careful when you're playing with these. This is a 24-volt model. It is a ball-bearing, brushless blower. Runs off of 24 volts DC. Now it claims to be rated at 0.4 of an amp, and that's pretty powerful. I think it will be more than adequate for my application. I will be running it on a solar panel which will never exceed 24 volts. In fact, it will never exceed about 20 volts. So this blower will be underpowered. However, it moves plenty of air. Now it isn't pretty, but I have melted a hole in this container here, and that's where the blower is going to blow the air out of. Who knows, I may pretty that up later, but right now I'm just going to try to get this working. The first step was to clean up the hole I made for the air outlet, and for that I used my cutters. These are meant for cutting wires, but I use them for cutting soft plastic all the time, and they work pretty good for that. You got to be careful with them as they're easy to bend. That's one of my favorite uses for this type of cutter, not actually cutting wire. It's time to mark where the blower is going to sit. I need to drill 4 holes and attach 4 fasteners to hold this blower in place. First I lined the blower up with the air exhaust outlet that I cut earlier. I got it lined up pretty good, but think about as good as it's going to get. I'm going to make sure it doesn't move, and I'm going to use this tool here to mark the plastic where I want to drill the first hole. Okay, so I made a small mark where the first hole will be drilled. Okay, there's the hole. So I need to temporarily use that hole to line the blower up. So I'll put a M3 bolt in there. This will line the blower up with the hole and hold it in place. Okay, now that I've got it lined up the way I want, I've got the other hole with a bolt through it. I'm going to go ahead and mark the second hole, which is right by this wire, making sure the blower doesn't move. And I think that's pretty good. It's not perfect, but it's pretty good. Okay, there's the next hole drilled. I'm not showing all the holes being drilled because it makes for a pretty boring video. Now I have 2 bolts to align the blower. Let's see how that worked out. So these are pretty much lined up the way I want them to be. So it worked out pretty good. Now I need to drill 2 more holes, but because it's next to this wall of the plastic box, I'll have to drill them from the outside. So I'm going to go ahead and mark those and get those drilled. Okay, I got all the holes drilled. It turns out there's only 3. So I may use something to anchor the 4th corner of this blower if I feel the need to, but I don't think it's a big deal. Now, in order to ensure the screw holes that the blower is mounted on do not leak air, and also to ensure that there are no aggravating vibrations or rattles caused by this blower operating in this plastic box, I'm going to use some of this rubber neoprene strip. Really, any rubber would do, but I really like this stuff here. I think I'll try it. And I'm going to make little mounting posts for the blower, which will seal around the screws, and they will also cushion the blower so that it doesn't vibrate too much. So I'll just simply take these squares or rectangles and put them right over the hole. I did plan to have a little bit of rubber below it, so I took that into account when I did my measurements. Now I'm going to install the nylon bolts behind the foam pieces. So I'm going to make a hole in the foam using a very small screwdriver, and it's smaller than the actual nylon screw itself, which is right here, so it will seal around it pretty good. Plus, when I tighten it down, it will seal even better. Okay, there's the 3rd mounting location. The next task is to seal around the exhaust vent. I don't want to have any air that's coming out of the blower go inside the case, and instead of going out here. So now I'm just going to go ahead and attach the rest of the neoprene foam rubber. I won't bore you with that, and I'll be right back. Okay, I've managed to get the foam all around the exhaust opening. Now I'm just doing the final installation of the blower into the case. Okay, the fitment is pretty good, and the foam is really cushioning the blower, so hopefully there won't be any rattles or vibrations. Now I just need to put the nylon nuts on the top to hold it in place. That's what I'm going to use right there. It's a nylon nut or standoff, and that also makes it easier to thread onto the bolt. Okay, there's the blower permanently installed inside the plastic box. The next step is to install a switch and a quality 2.1mm DC jack to power it. Okay, there's the 2.1mm jack, and I really like these kind. These are really high quality metal ones, not the cheap plastic ones you normally find. The switch I'm going to install is simply a 12-volt automotive switch. I will put the switch pretty close to the power jack, so I think right about here will be fine. little bit of heat shrink and solder, and it's relatively simple to hook up, just a positive and a negative. It's going to go straight to the blower through the switch. There is no electronic devices or anything to worry about other than that. Okay, it's actually the next day. Next step is I want to put some RGB LEDs into the filter. If I'm looking at it from a distance, I want to be able to see that it's on, so these LEDs would tell me that. And plus, they'll look really, really cool. Now, I'm not going to bore you with soldering all these together. I'm just going to put a bunch of them in series, and they're going to attach to the DC input on the filter, and they will glow when the electrical power is feeding in. Okay, here's the LEDs. I've soldered 7 to 8 of them in series. This way I don't need a current limiting resistor. The solar panel will never put out more than about 21 to 22 volts at the very best case, and I doubt it will go that high. And these LEDs can handle about 23 volts without any problem at all. The LEDs say they have a 3 to 3.2 volt 4 voltage drop. I'm just going to say 3 volts because I want the worst case scenario. If I multiply 7 times 3, I get 21 volts. My solar panels could put out over 21 volts. If I multiply 8 times 3, that's 24 volts. My solar panel will never ever see 24 volts. That's not possible. So now I'm connecting in my RGB LEDs. And I'm not going to show every detail. I don't want it to get too boring. But I've got to solder it onto this 2.1 millimeter jack here. And the other side is going to go to the switch. This side goes to the power jack. Now I have not done all the heat shrink just yet because I may want to make changes to this later, so I've learned not to heat shrink myself into a corner. My guess is I may make changes, change out the switch or change the LEDs or something like that. Okay, so there's the LED power feed coming off the switch, and then there's a power feed for the fan. This is all very simple stuff. It looks a little bit complicated, but it's actually very simple. Now I'm going to hot glue my LEDs onto the side of the case here. Okay, it's time for the moment of truth. I've soldered in the LEDs. I cut out a lot of the detail because I don't think people want to see a lot of soldering. But the LEDs are just soldered in series or soldered to a pair of wires which go down to the switch and the power jack. Okay, it's time to test this thing to see if it will work. And this is how it's going to sit on my desk. Actually, it's a workbench. And it's going to probably eventually have something underneath, maybe some feet, but I'm just going to test it like this for now. Filter is in there pretty good, it's snug. So let's go ahead and give it a try and see what happens. Okay, here's a power cord. This is connected to a 100 watt solar panel. I'm just going to plug that right in the side here. Now, if you don't want to use a solar panel, all you need is a DC adapter. So don't worry about that. If you don't have a solar panel, just use a laptop adapter or something like that. Okay, let's turn it on and give it a test. And it turns right on. Now, another option for this would be a speed controller to turn the fan up and down to different speeds, but I'm just going to leave mine the way it is. I can feel the air. Yeah, it's definitely moving some air across the filter. I don't say it's moving too much, but it's moving enough. And the RGB LEDs are lit up. Let's see if I can get some better footage of that. There we go. Actually, it looks pretty nice. Now, right now it's running on a lesser voltage. I designed this to run off of different voltages, so very wide voltage array. There's a nice amount of air coming out the side. I do need to add a grill over the exhaust outlet because there is a risk someone could stick their finger in there. Well, my workbench is getting a bit crowded. Now I have a solar-powered HEPA air filter, a solar-powered Ryobi 18-volt battery charger, a solar-powered Ryobi 18-volt hot glue gun, and not shown here is my Ryobi 18-volt soldering iron, which is also powered by solar. And then there's the overhead lighting, which is also powered directly off of a solar panel. What I like about using the solar power directly is there's no batteries, no charge controller. When the sun comes out in the morning, everything just starts working. It runs for free. You don't have to worry about it. And at the end of the day, if you need to keep working, you can always bring in a battery. Otherwise, you probably aren't even there in the shop and you're already doing something else because it's nighttime. And in the morning, when the sun comes out, everything starts working again for free. Doesn't cost you anything. I hope you enjoyed this video about making a solar-powered HEPA air filter. Thanks for watching, and I'll see you later.